Hello, and welcome to the Evaluating Trig Inverses Day 3 video. You may notice that I'm introing this like my normal videos. That's because I'm filming this in the now time, not last spring, so you're not going to get any buzzwords. There's not going to be a ton of new material in this video. It's more of just kind of recapping what we've done and practicing more problems. So let's get started. Part of that recap, instead of doing a circle for every single problem, I'm just going to draw all my circles at the top so that you have that at the top of your notes to go back and look at. So just a reminder, for sine inverse, we are going through and we are only looking at quadrants 1 and 4. So we're only looking right here. And that is because we took the sine function and we restricted the domain to negative pi over 2 to pi over 2 including, so we're using brackets there. So that's where we're looking whenever we're talking about sine inverse. For cosine inverse, we are looking quadrants 1 and 2 between 0 and pi. And that is because we restricted the domain of cosine from 0 to pi including. And then for tangent inverse, that's not a great circle, that's okay. It's restricted similarly to sine, but this is when we changed or restricted the domain of tangent from negative pi over 2 to pi over 2, but not including. So we're going to be using parentheses there. So I do want you to keep that in mind as we go through and we take a look at tangent inverse. But sometimes I like to just draw all three of these at the top of my page so that as I work through, I can go back and take a look. So feel free to write these down each time if you want, or just at the top. But we're going to go through just 4 problems to practice together. So I'm filming this after doing the evaluating day 3 go formative answer key, and I realized one of the problems is the same. So we're not going to go over that one in class. That's okay. So let's see, let's take a look. Like I said, 4 examples. Example number 1 is going to be sine of tangent inverse of -1. So whenever we have composition of functions like this, and the inner one is an inverse, you can draw a triangle for this if you want. However, you don't necessarily have to because of that -1 there. That -1 is in fact something on our unit circle. So if I look just at this inner function, tangent inverse of -1, well, I'm going to go back to my picture I drew. -1 is going to be down here in quadrant 4. And we've actually already found tangent inverse of -1 before. That's going to be at negative pi over 4 because we have square root of 2 over 2 and negative square root of 2 over 2 as our x and our y value. So anything divided by itself is going to give us 1. And then the positive and negative is going to give us a negative there. So we have this answer for our inner function, and then we're going to say, hey, sine of negative pi over 4, we're going to go back and plug that in. Well, just what is the y value at negative pi over 4? Like I just said, that's negative square root of 2 over 2. So we have sine of tangent inverse of -1 is equal to negative square root of 2 over 2. I do like you writing this last statement just because sometimes the work can get a little bit messy and it's nice to have just one place to read the final answer. Anyway, that's problem 1. Let's head to problem 2. So problem 2 is the problem that is also on our go formative. So if you watch this video, you're going to know that this is problem, I think it's like 3 or 4 maybe, problem 3. Anyway, so same type of thing. We have composition of functions with an inverse on the inside. You can draw triangles for this. However, square root of 2 over 2 is on the unit circle. So when I think of, oops, I forgot to change my pen. When I think of sine inverse of square root of 2 over 2, again, you can draw a triangle, but if we take a look up here, square root of 2 over 2, that's in quadrant 1, that's going to be at pi over 4. Then we're going to take that, plug that into our outer function, and have cosine of pi over 4. And that's going to be square root of 2 over 2. So our final answer here is cosine of sine inverse of square root of 2 over 2 is equal to square root of 2 over 2. And I wanted to go over this problem because it looks like the cosine and the sine inverse are canceling each other out, but that's not what's happening. Remember, a lot of things start to repeat on our unit circle, so sometimes it looks like things are canceling, but it's really just where we're looking at that specific answer. So I want you to be really careful about that. Our next two problems, we are going to be drawing on unit circles, or probably not drawing on unit circles, drawing triangles. So let's take a look at 3 and 4. So for problem 3, we are going to have secant of tangent inverse of 1/2. Now, taking a look at this, tangent inverse, or pardon me, 1/2 is on the unit circle, but only for sine and cosine, not for tangent. So that's kind of giving me the hint of, hey, I have a composition of functions, I have an inverse on the inside, and then I have something that I don't recognize on my unit circle. So just a reminder, that tangent inverse of 1/2 is really theta. And we're using this unknown theta to help us set up our triangle. So for tangent of some of this theta, we know it's equal to 1/2, but tangent in general is also opposite over adjacent. So when we build our triangle, it's going to look something like this. Oop, these triangles do not have to be drawn to scale. So if here's our theta, our opposite side is 1, our adjacent side is 2. Now we want to go through and find our hypotenuse. I'm going to do that using Pythagorean theorem. So if 1 squared plus 2 squared gives me that c squared, or hypotenuse squared. 1 plus 4 gives me c squared. 5 is equal to c squared. So we have the square root of 5 is equal to c. Now, when I think about secant, I want to find secant of theta. Well, reminder, secant of theta, secant is the flip or reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent, meaning that secant of theta in this case is square root of 5 over 2. So overall, we can say that secant of tangent inverse of 1/2 is the square root of 5 over 2. So hopefully not too bad if you know your SOHCAHTOA. You're going to be okay. We got one last problem. I think it's doable. The only tricky part is you are simplifying under a radical, which you may not remember how to do. So let's get to it. Problem number 4 is tangent of sine inverse of 1/3. So again, composition of functions, inside function is an inverse. I don't recognize this on my unit circle. Let's draw a triangle. So let's see, this right here is really my theta. So we know that sine of theta is 1/3, and sine is opposite over hypotenuse. So when we draw our triangle, ooh, that was wavy. Here's our triangle. Our opposite side is 1. Our hypotenuse is 3. We're going to go through, solve for that last side. So 1 squared plus b squared is equal to 3 squared. So 1 plus b squared is equal to 9. Subtract 1 on both sides, square root. And we get b is equal to square root of 8. But the thing is, that can be simplified, and this may help us simplify things later on. So just a reminder how to simplify. You can break up square root of 8 into square root of 4 times 2. And because we're multiplying, we can take the square roots of these separately. So the square root of 4, well, square root of 4 is just 2. But the square root of 2, that can't be simplified. So that has to stay underneath the square root. So we're actually going to say that b is equal to 2 times the square root of 2. So when we're going through and we're plugging this back in and we're trying to find tangent of theta, just a reminder, tangent is the TOA of your SOHCAHTOA, so that's opposite over adjacent. So we're going to have, let's see, I'm going to move this just a little bit. There we go. We're going to have that tangent of theta is opposite, 1, over adjacent, 2, times the square root of 2. So what we're going to do here, don't like square roots in the denominator. We are, in fact, going to rationalize this still. we're going to end up with square root of 2 over 2 times square root of 2 times square root of 2, which is 2. Or, I guess I can leave it like that, square root of 2 over 4. So overall, we can say that tangent of sine inverse of 1/3 is equal to the square root of 2 over 4. So overall, not too tricky. I just wanted to remind you about rationalizing under the denominator. So hopefully nothing in this video was too new. I just wanted you to keep this in your brain so you didn't lose it over the weekend. Let me know if you have any questions. I look forward to seeing you on Monday.